Hello, good morning. Here's our presentation on GNU Fortran. Fortran, from formula translation, is a general-purpose compiled imperative programming language that is best suited to numerical and scientific computing, for which it has been in use for 6 decades. GNU Fortran was developed by the developers at GNU Project, who develop and publish a variety of free software to give users freedom and control in the use of their computers. This was developed between 2001 and 2005, with the initial release in April 2005 replacing the old G77 compiler. Since the principal author, Craig Burley, and maintainer of G77, stopped work on it in 2001, the G-Fortran project aimed to develop new Fortran front-end and runtime libraries for GCC. G-Fortran includes full support for Fortran 95 with partial support for Fortran 2003 and 2008. It does support large parts of 2003 and 2008, but not everything, which is somewhat disappointing. Fortran was the world's first high-level language, so this is unsurprising. COBOL and Lisp actually came out around the same time, 2 years and 1 year later respectively after Fortran. This is the compilation process. The Fortran file, filename.f, is fed into the C preprocessor for the Fortran frontend. This goes to the optimizing code generator, which outputs a .o file. We'll talk about the .o file in a bit. Next comes the linker, which outputs the a.out file after output. The source file in Fortran ends with the extensions .f, .F, .for, .for, or .i. This compiler has an integrated C preprocessor that provides full C++ capabilities. The compiler produces a linkable object when the flag C command is specified. It takes the original file name, but the output has the extension .o, which was mentioned in the previous slide as output. The executable file is a.out by default. Another name can be specified for the executable using the -o name command. So here are some of GNU Fortran's greatest strengths. The efficiency of compiled code is quite high because Fortran is straightforward to compile and the techniques for handling it have reached a great degree of refinement throughout the years. It is free and thus easily available to all. Being open source, development is fast and anybody can contribute to this to improve and add upgrades. GNU Fortran can be used with multi-threading in programs and it also guarantees thread safety. One more thing to note is that the compiler does not evaluate all parts of an expression, so the result can be arrived at without needing all the parts. Asynchronous input-output is supported if the program is linked against a POSIX thread library. If not, all I/O performed is synchronous. For consistency, buffered I/O is used in order to improve performance, and this buffer is automatically flushed whenever necessary after the buffer is full. Now let's look at some glaring weaknesses. Weaknesses are expected from this because this compiler has since been replaced. So the first weakness is that GNU Fortran does not support the latest Fortran standards, which is 2018. In fact, as mentioned earlier, it does not even offer full support to the 2003 and 2008 standards. And when we're talking about durability, GNU Fortran does not ensure that data is committed to stable storage. So this is entirely left to the programmer to code for it. One more thing to note is that GNU Fortran creates a name.mod file for each module name. So this confuses the make of GNU into thinking they are modular to source file, and the user must manually override this with a command. Block data in GNU Fortran causes trouble with linking and initializing. Sharing common blocks across Fortran tasks is somewhat tedious to programmers. Some programs make use of overflow variables for a desired result. GNU Fortran throws an arithmetic overflow error immediately and must be forced to accept it manually. GNU Fortran's error messages do not comply to pattern in Emacs compilation error rejects A list. So, in conclusion, Fortran has been around for so long, so you have to expect that it runs just about on any system, give or take. It is also compatible with a wide variety of systems, a necessity given that it was an open source project to begin with. As such, given that Fortran is so widespread, so it is a reliable compiler for the same. Here are some other compilers which match what we were looking for, and we ended up choosing Fortran in the end. For embedded systems, we have Kale, Code Composer Studio, GNU GCC, and RIDE 7. For small devices, we have the SDCC, which is the small device C compiler, and the TCC, which is the tiny C compiler. For parallel programming, we have ROSE, Intel Fortran compiler, and the C++ Intel compiler. And for graphics, we have the Intel graphics compiler. Thank you.